How often do you wonder about the limits of the computer you're using right now? It's a question that may seem odd, but it's one that is more pertinent than ever. We live in a world of rapid technological advancement, where the devices that power our lives are becoming increasingly sophisticated. But even as our computers become more powerful, they're still bound by the laws of classical physics. Think about it. The computer you're using right now, whether it's a smartphone, a tablet, or a desktop, operates on binary code, a series of ones and zeros. These ones and zeros, known as bits, are like tiny switches that can be either on or off. Despite its simplicity, this binary system underpins all of modern computing, but it has its limits. As we push the boundaries of what our computers can do, we're starting to hit a wall. There's only so much data you can process with ones and zeros. There's only so much information you can store in a finite amount of space. And there's only so fast you can go before you start running into problems like overheating and energy consumption. But what if there was a way to bypass these limitations? What if we could step outside the realm of classical physics and tap into the strange world of quantum mechanics? Enter quantum computers. Unlike our conventional computers, quantum computers don't operate on bits, but on quantum bits or qubits. These qubits can be both 1 and 0 at the same time, thanks to a quantum quirk known as superposition. This means that quantum computers can process a vast amount of information and solve complex problems that our current computers would struggle with. They're not just theoretical either. Quantum computers exist today, and they're getting more powerful year by year. It's a new computing era, one where the rules are being rewritten and the possibilities are endless. Imagine a world where these limitations no longer exist. Welcome to the world of quantum computing. But what exactly is quantum computing? Sounds intimidating, doesn't it? Well, let's strip away the mystery. Imagine you're in a library filled with books, and you're looking for a specific title. In a traditional computer, it's like reading each book one by one until you find the one you're seeking, but with a quantum computer, it's as if you can read all books at once. This all-at-once ability comes from a quantum principle called superposition. In our everyday world, something can be in one state or another. An on and off switch, for instance, is either on or off. But in the quantum world, things can be in a superposition of states, meaning they can be in multiple states at the same time, just like reading all books simultaneously. Now, let's introduce another peculiar quantum concept: entanglement. Imagine having a pair of dice. You roll them, and no matter how far apart they are, they always show the same number. That's entanglement in a nutshell. In the quantum world, particles can become entangled, meaning the state of one particle is instantly connected to the state of another, no matter the distance between them. This instant connection allows quantum computers to process information in a highly interconnected way, which is vastly different from how traditional computers work. So, how does this all tie into computing? Well, traditional computers use bits, which can be either a 0 or a 1. But quantum computers use quantum bits or qubits, which, thanks to superposition, can be a 0, a 1, or both at the same time. This allows quantum computers to process a huge number of possibilities all at once. Entanglement adds another layer to this. Because entangled qubits affect each other instantly, a change to one qubit can instantly change others, making computations even faster. In essence, quantum computers can process immense amounts of data simultaneously, unlike traditional computers. Where did this concept originate from? Who were its pioneers? Quantum computing, a term that has become increasingly popular in recent years, isn't as modern as you might believe. Its roots can be traced back to the early 20th century, when notable physicists were grappling with the mysteries of quantum mechanics. The concept of quantum hails from the Latin word for how much, and in the realm of physics it relates to the discrete nature of energy and matter at the smallest scales. Fast forward to the mid-20th century, a man named Richard Feynman, a Nobel Prize-winning physicist, proposed a radical idea. In 1982, Feynman suggested that a quantum computer would be able to simulate the universe, a task impossible for classical computers. His visionary idea paved the way for the development of quantum computing, but the story doesn't end there. In 1994, a mathematician named Peter Shor developed a quantum algorithm, aptly named Shor's algorithm, that could factor large numbers into primes significantly faster than any classical computer. This breakthrough brought the theoretical concept of quantum computing into the realm of possibility, and it sent shockwaves through the world of cryptography, where the security of many systems relies on the difficulty of factoring large numbers. Since then, the field has been progressing at an exhilarating pace. From David Deutsch, who formulated the mathematical foundations for quantum computing, to the teams at IBM, Google, and other tech giants who are actively developing practical quantum computers, we've witnessed an incredible journey of scientific and technological advancement. Quantum computing, a concept that began as a mere hypothesis, has grown into a global endeavor. Its development is marked by the collective efforts of brilliant minds across the globe, each contributing to the unraveling of this complex and fascinating technology. Despite its seemingly recent popularity, the concept of quantum computing has been around for quite some time. And as we delve deeper into its intricacies, it's clear that we're only scratching the surface of its potential. But one thing's for certain: the pioneers of quantum computing have set in motion a revolution that's poised to redefine our understanding of computation. Fast forward to today, where does quantum computing stand? In the world of technology, changes are happening at breakneck speed. Quantum computing, once a far-off dream, is now a reality, and it's altering our technological landscape in unprecedented ways. The potential of quantum computing is immense, and it's already making waves in various industries, from cryptography to drug discovery and from climate modeling to financial modeling. At the forefront of this quantum revolution are a handful of companies and research institutions. Tech giants like Google, Microsoft, and IBM are investing heavily in quantum research and development. Google's quantum AI team, for instance, is focused on building quantum processors and developing novel quantum algorithms to improve computational tasks. They even claimed quantum supremacy in 2019, a term used when a quantum computer performs a calculation that no classical computer could achieve in a reasonable time frame. IBM, on the other hand, has been a pioneer in this field for years. They've made quantum computing accessible to the public through IBM Quantum Experience, an online platform where anyone can run experiments on IBM's quantum processors. Research institutions are also making significant strides. Universities such as MIT, Caltech, and Oxford are fostering innovation in quantum computing through their dedicated research programs. However, it's not just about the big names. Startups like Rigetti Computing and IonQ are also making significant contributions. Rigetti Computing, a California-based startup, is developing both the hardware and software for quantum computers, while IonQ is focusing on trapped ion quantum computing, a different approach to quantum technology. It's important to remember that we're still in the early days of quantum computing. While we've made significant strides, there's still a long way to go. Quantum computers are still prone to errors and require incredibly precise conditions to function. But the progress we're witnessing is encouraging. Quantum computing is no longer a far-fetched theory, but a tangible reality. It's an exciting time to be part of this quantum journey, and we can't wait to see where it takes us next. So what does the future hold for quantum computing? As we move forward into the 21st century, the potential applications of quantum computing are as vast as they are exciting. Imagine, for instance, a world where diseases are no longer a menace. With quantum computing, we could model complex molecular structures, helping us to understand diseases better and develop effective drugs faster. In the realm of artificial intelligence, quantum computing could be a game changer. AI systems powered by quantum algorithms could learn and adapt at an unprecedented rate, outstripping anything we've seen thus far. We're talking about machines capable of processing vast amounts of data and making complex decisions in a split second. The field of cryptography too may be revolutionized. Quantum computers could crack current encryption codes like a nut, rendering them obsolete. On the flip side, they could also create new unbreakable codes, ushering in a new era of security. Yet, despite its enormous potential, the road to a fully functional quantum computer is not without its challenges. Quantum bits or qubits are incredibly sensitive. They require precise control and an environment free from any form of interference. Maintaining such conditions is a formidable task. Moreover, quantum algorithms are complex. To harness the full potential of a quantum computer, we need to develop algorithms that can effectively utilize the principles of quantum mechanics. This requires a deep understanding of both computer science and quantum physics, a combination that is quite rare. And then there's the issue of scalability. Building a quantum computer with a large number of qubits is a significant technological challenge. The more qubits you add, the more complex the system becomes, and the harder it is to maintain. Yet, despite these hurdles, the potential rewards are immense. Quantum computing could reshape our world, redefine our understanding of the universe, and push the boundaries of what's possible. The quantum future may seem a bit distant, but it's a journey well worth embarking on. The road to a quantum future is not without its hurdles, but the potential rewards are immense.